Today we are going to solve some problems on the chapter Principle of Mathematical Induction. Now let us recall the principle of mathematical induction. Let P and be a mathematical statement involving a natural number n, that is n belongs to capital N. Now if number 1 P1 is true, that is the statement is true for natural number n equal to 1. Number 2, P m plus 1 is true whenever Pm is true, where m and m plus 1 are natural numbers. Then we say that Pn is true for all natural numbers. This is the principle of mathematical induction. Now, in my previous video, we said that we are going to solve the problems by the following method, TAPE, by the following formula TAPE, where TAPE means T for test, A for assumption by assume, P for prove, and E for explain. By these steps, we are going to solve our problems. The first problem is sum of the cubes of 3 consecutive natural numbers is divisible by 9. Let the 3 consecutive natural numbers be n plus 1 and n plus 2, where n belongs to capital N. Then the statement Pn such that n cube plus n plus 1 cube plus n plus 2 cube is divisible by 9. Now P1, that is 1 cube plus 1 plus 1 cube plus 1 plus 2 cube equal to 1 plus 2 cube plus 3 cube equal to 1 plus 8 plus 27 equal to 36, which is divisible by 9. Therefore, P1 is true. Now, let us assume that the statement Pn is true for some natural number m, that is for n equal to m, that is m cube plus m plus 1 cube plus m plus 2 cube is divisible by 9. Now we have to show Pm plus 1 will be true whenever Pm is true. That is Pm plus 1 is m plus 1 whole cube plus m plus 1 plus 1, that is m plus 2 whole cube, m plus 1 plus 2, that is m plus 3 whole cube. equal to, now we have to calculate it, equal to m plus 1 cube plus m plus 2 cube. And now I am going to expand this with the help of a plus b whole cube formula. M cube plus 3m square into 3 plus 3 into m into 3 square plus 3 cube equal to m plus 1 cube plus m plus 2 whole cube plus m cube plus 9m square plus 27m plus 9 equal to m cube plus m plus 1 whole cube plus m plus 2 whole cube plus 9 m square plus 3m plus 1 equal to pm plus 9 into m square plus 3m plus 1. This portion is pm and this is divisible by 9, therefore the total pm plus 1 is divisible by 9. Then which is divisible by 9. Therefore pm plus 1 is true whenever pm is true. Therefore by the principle of mathematical induction, Pn is true for all n. N belongs to capital N or n is a natural number. Next, if small n belongs to capital N, then n cube plus 3n square plus 5n plus 3 is divisible by 3. Let Pn be the statement n cube plus 3n square plus 5n plus 3 which is divisible by 3. Now, for n equal to 1, that is P1, 1 cube plus 3 1 square plus 5 into 1 plus 3 equal to 12, which is divisible by 3. Now let us assume that Pn is true for some natural number n equal to m, that is Pm m cube plus 3m square plus 5m plus 3 which is divisible by 3. Now what is Pm plus 1? That is m plus 1 tar whole cube. Now m plus 1 whole cube plus 3 into m plus 1 whole square plus 5 m plus 1 plus 3 equal to m cube plus 3m square plus 3m plus 1 plus 3m square plus 6m plus 3 plus 5m plus 5 plus 3 equal to m cube plus 3m square plus 5m plus 3 plus 3m plus 6 3m square plus 9m plus 9 equal to, this is Pm plus 3m square plus 3m plus 3. Pm is divisible by 3 and this is divisible by 3, therefore is divisible by 3. Therefore Pm plus 1 is true whenever Pm is true, and there is P1 is true. Therefore P1 is true and Pm plus 1 is true whenever Pm is true for some natural number m. Pm plus 1 is true whenever Pm is true for some natural number m. P1 is true. Therefore, by the principle of mathematical induction, Pn is true. That is m cube plus 3m square is divisible by 3. Pn is true, that is n cube plus 3n square plus 5n plus 3 is true for n belongs to capital N or for all natural numbers. Next, 5c n to the power 7 by 7 plus n to the power 5 by 5 plus 2n cube by 3 minus n by 105, where n is a natural number, is an integer. Let Pn be the statement where Pn, this expression is an integer where n belongs to capital N. Now, we have to test. First part T, test. Now we test that whatever P1 is true or false. Therefore, P1 for n equal to 1, P1 is 1 to the power 7 by 7 plus 1 to the power 5 by 5 plus 2 into 1 to the power 3 by 3 minus 1 by 105, which is equal to 105. LCM, denominator is the LCM 105. 7 15 plus 21 plus 70 minus 1 equal to 105 by 105 equal to 1, which is an integer. Therefore, P1 is true. Now, take the part A, that is we are going to assume. Let us assume that Pm is true for some natural number m, that is m to the power 7 divided by 7 plus m to the power 5 divided by 5 plus 2 m cube by 3 minus m divided by 105 is an integer. Now we have to prove that Pm plus 1 is true whenever Pm is true. Now what is the value of m plus 1 or 1 plus m whole to the power 7? That is 1 plus x whole to the power n. What is the binomial expression of the term 1 plus x whole to the power n? Equal to nc0 plus nc1x plus nc2x square plus nc3x cube plus dot 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 plus ncn x to the power n, where NCR means factorial n divided by factorial r into factorial n minus r, or 1 plus x whole to the power n equal to 1 plus nx plus n into n minus 1 divided by factorial 2 into x square plus n into n minus 1 into n minus 2 divided by factorial 3 into x cube and so on. Therefore, 1 plus m whole to the power 7 equal to 1 plus 7m plus 7 into 7 minus 1 by factorial 2 into m square plus 7 into 7 minus 1 into 7 minus 2 divided by factorial 3 into m cube plus 7 into 7 minus 1 into 7 minus 2 into 7 minus 3 by factorial 4 into m to the power 4 plus 7 into 7 minus 1 into 7 minus 2 into 7 minus 3 into 7 minus 4 divided by factorial 5 into m to the power 5 plus 7 into 7 minus 1 to 7 minus 2 into 7 minus 3 to 7 minus 4 to 7 minus 5 divided by factorial 6 into m to the power 6 plus m to the power 7. First part. Now 6 factorial 2 means 2 2 3 is a 6 3 2 6 6 m square 6 factorial 3 means 6 6 6 cancel out, then 5 and 5 in 7 35 m cube and so on, equal to 1 plus 7m plus 21 m square plus 35 m cube plus 35 m to the power 4 plus 21 m to the power 5 plus 7 m to the power 6 plus m to the power 7. You see there is the term 1 and the coefficient of m cube is 1. Coefficient of m is 7, coefficient of m to the power 6 is 7. 21 21 35 35. In this way we get 1 plus m whole to the power 5 equal to 1 plus 5m plus 10m square plus 10m cube plus 5m to the power 4 plus m to the power 5. Expand all the terms and finally we get this. Now we have to calculate more 2 steps. These plus these plus these plus these, that is PM, and the red colors are adding, the result is this, and the pink color are those and they are adding, we get this, because since 1 by 7 plus 1 by 5 plus 2 by 3 minus 1 by 105 equal to 1. It is clear that this is a integer, which is an integer, Now P1 is true. Pm plus 1 is true whenever Pm is true. Therefore, by mathematical induction, Pn is true for all natural numbers. Next problem, 1 plus 1 by 4 plus 1 by 9 plus 1 by 16 plus dot 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 plus 1 by m square less than 2 minus 1 by m, where m greater or equal to 2 and m is a natural number. Let the statement be Pm this. Now what is P1? Now P1, P2, this is not P1, this is P2, P2. Since the natural number starting for 2, then we are going to test whenever P2 is true or false. P2 means left hand side 1 plus 1 by 4 and right hand side 2 minus 1 by 2 is 2, 4 minus 1, 3 by 2 1 plus half. This is 1 plus 1 by 4, 1 plus 1 by 4. Therefore, 1 plus 1 by 4 less than 1 plus half. Therefore, P2 is true. Now, let us assume the statement Pm is true for some positive integer k, where k greater or equal to 2 and k belongs to n. That is 1 plus 1 by 4 plus 1 by 9 plus dot 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 plus 1 by k square less than 2 minus 1 by k. Now, what is pk plus 1? 1 plus 1 by 4 plus 1 by 9 plus dot 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 plus 1 by k square plus 1 by k plus 1 whole square, which is less than 2 minus 1 by k plus 1 by k plus 1 the whole square, because this term is less than 2 minus 1 by k, therefore 2 minus 1 by k and this term is same. Now there is a calculation. Now k plus 1 greater than k for k greater or equal to 2, and k plus 1 into k plus 1 greater than k into k plus 1, both side multiplied by k plus 1, or k plus 1 whole square greater than k into k plus 1, or 1 by k plus 1 the whole square less than 1 by k into k plus 1. Substitute this value here, less than 2 minus 1 by k plus 1 by k into k plus 1, which is equal to 2 minus 1 by k, 1 minus 1 by k plus 1, equal to 2 minus 1 by k, k plus 1, k plus 1 minus 1, equal to 2 minus 1 by k plus 1. Therefore, pk plus 1 is also true where pk is true. Therefore, P2 is true and pk plus 1 is true whenever pk is true. Therefore, by principle of mathematical induction, Pm is true for all m greater or equal to 2 and m is a natural number. Next, if k belongs to n, then 1 plus 2 plus 3 plus dot 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 plus k less than 2k plus 1 whole square by 8. Let pk be a statement where pk 1 plus 2 plus dot dot plus k less than 2k plus 1 whole square by 8. Now we have to prove that p1 is true. Then p1 1 হচ্ছে 2 plus 1 whole square divided by 8, that is 9 by 8. Therefore 1 less than 9 by 8. Therefore P1 is true. Now the portion is assumption portion. Let us assume that Pm is true for some natural number n, that is 1 plus 2 plus 3 plus dot 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 plus m less than 2m plus 1 whole square divided by 8. Now we have to prove that Pm plus 1 is also true. So now 1 plus 2 plus 3 plus dot 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 plus m plus 1, which is less than 2 into 2m plus 1 whole square divided by 8 plus m plus 1, equal to 2m plus 1 whole square plus 8m plus 1, equal to 2m plus 1 the whole square plus 2 into 2m plus 1 into 2, 2 2s are 4, plus 8 plus 2 square, 2 to the 4, 2 the 8, 8m, 2 to the 4, 4, 8 equal to 2m plus 1 plus 2 whole square equal to 2m plus 3 whole square divided by 8 equal to 2 into m plus 1 plus 1 তার whole square divided by 8 তাহলে which is less than 2 into m plus 1 plus 1 তার whole square divided by 8 তাহলে therefore pm plus 1 is true. Therefore pm plus 1 is true when pm is true. Therefore by principle of mathematical induction pk is true for all natural number k.